as you look at part E, notice that neither side is a 0. So the first thing we need to do is get a 0 on one side or the other. Now, traditionally I like to have the 0 on the right-hand side. So what I'm going to do is subtract the expression on the right-hand side from both sides so that we end up getting the 0 on the right. So I'm going to have 1 divided by x plus 2, and then I'm going to subtract over the 3 divided by x plus 1, and it's going to be less than or equal to 0. Now, the next thing that I want to do then is to try to make this E problem look more like the previous two problems. Instead of having a subtraction problem that have two little rational expressions, I would like this to be one big rational expression on the left-hand side. So in order to bring these two rational expressions together, we're going to have to find the LCD. And the LCD in this problem then is going to be the product of our two denominators, x plus 2 and x plus 1. So now that I know that my LCD is x plus 2 times x plus 1, I need to look at each one of these rational expressions and try to figure out how to create that LCD for each one of those rational expressions. So 1 divided by x plus 2. When I compare the current denominator to the LCD, you're going to notice that the factor that's missing is x plus 1. So I'm going to come in and multiply the denominator by x plus 1. But I can't randomly go and multiply denominators by things and expect this to be an equivalent problem. So if I multiply the denominator by x plus 1, I also need to multiply the numerator by x plus 1 as well. Now, the cool thing about this is that what really just happened here is I multiplied by x plus 1 divided by itself. Anybody divided by himself like that is going to end up being an equivalent version of the number 1. Multiplying by a 1 doesn't change the value of the fraction. So again, anytime you multiply the denominator by something, you're going to multiply the numerator by exactly that same piece to keep it equivalent to the original problem. Well, okay, let's go ahead and check out the next one then. Our first piece then, 3 divided by x plus 1. But when I compare this current denominator to the LCD, the missing factor is an x plus 2. So I need to multiply this denominator by x plus 2 to create the LCD. But if I multiply the denominator by x plus 2, I need to multiply the numerator by x plus 2 as well. And this is less than or equal to 0. So now I'm going to come in and do some multiplications and then some simplifications. 1 times x plus 1 is going to be x plus 1. And then here, you want to make sure that you're thinking about this as a negative 3. So we have a negative 3 times the quantity x plus 2. Negative 3 times x is going to be negative 3x, and negative 3 times that positive 2 is going to be negative 6. And then this is all divided by the LCD. So it's going to be x plus 2 times x plus 1. And this is less than or equal to 0. So now, as I look at that numerator, I can bring some things together. I have x and negative 3x, those are like terms. X minus 3x is going to be negative 2x. Positive 1 and negative 6, those are like terms. They can come together as a negative 5. And again, all of this is divided by the LCD. So we have x plus 2 times x plus 1, and this is less than or equal to 0. So at this point then, we have something that is much more like parts C and D. Now, one thing that I can do to make this a little bit prettier is to pull out a factor of negative 1 in that numerator. So let's go ahead and do that. If we pull out that negative 1, we then have 2x plus 5, and then we have x plus 2, x plus 1, and this is less than or equal to 0. So at this point then, we have a problem much more like the previous problems, and we're ready to think about what happens in terms of our sign chart. So when you think about the sign chart, you once again come in and you find all the interesting x values that are coming out from your inequality there. So we have a negative 1, nothing interesting from that. 2x plus 5, if you set that equal to 0 and solve, you're going to get negative 5 halves. So let's go ahead and put negative 5 halves here. X plus 2, well, x plus 2 as a factor means that negative 2 is going to be the 0. Now, in order to make sure that I place this correctly, think about the fact that negative 5 halves is really negative 2.5. So negative 2 would have to be to the right of that. And then negative 1 is going to be to the right of that, because x plus 1, when we look at the 0 for that, we're going to get negative 1. So now we need to look at each one of these regions, determine what's happening in terms of our signs, and then we can answer the question. So negative 5 halves, something to the left of that. Well, x equals negative 3 lives there. So think about what happens then when I look at each one of these factors and plug in a negative 3. This time, however, you have to be aware of the fact that this negative 1 is going to affect the sign as well. So each time that I write down my positives and negatives, I'm going to start by saying that we're going to have a negative because of that negative 1. So, okay, there's my negative for my negative 1. And then if I plug a negative 3 in here, it's going to be 2 times negative 3. That's negative 6 plus 5. That's a negative as well. So we have 2 negatives in the numerator. And then the denominator. Plug in a negative 3. We're going to have a negative in both of those factors. So once again, I have 4 negatives. 4 negatives, even number of negatives, that means that we're going to have a positive in that region. Now between negative 5 halves and negative 2, again, I have to find something that lives between those, and I'm going to have to choose something that's decimal to live between those because they're so close together. So let's choose something like negative 2.1. Negative 2.1 would live between negative 2.5 and negative 2. So let's again think about what's going to happen when we plug in that x value of negative 2.1. First factor, once again, is always going to be negative here. I'm going to come down just a little bit to do this. So there's my negative. And then if I plug in an x value of negative 2.1, 2 times negative 2.1 plus 5, this time that's going to be positive. And then we're going to have negative 2.1 plus 2. That's going to be negative. Negative 2.1 plus 1, also going to be negative. This time I have 3 negatives. That means that we're going to have a negative in that region. Between negative 2 and negative 1, we're going to have an x value like negative 1.5 there. So let's figure out what's happening in terms of our signs for negative 1.5. Once again, because of the negative 1, I have a negative there. And then 2 times negative 1.5 plus 5, that's going to be a positive. Negative 1.5 plus 2, that's a positive. Negative 1.5 plus 1, that's a negative. So we have 2 negatives. That means we're going to be positive again. And then finally, we need something to the right of negative 1. Now, luckily, x equals 0 lives there. So that's pretty easy to play with. So, okay, negative again. And then 2 times 0 plus 5, that's going to be positive. 0 plus 2 is going to be positive. 0 plus 1 is going to be positive. So we have 1 negative there. That means we're going to have a negative result there. Well, okay, let's go ahead and go back to our inequality here. This one was a less than or equal to 0. So the less than part is saying that we're interested in y values that are negative. So let's find all the regions where we have negatives. Positive, nope. Negative, interested in this region then. So I'll color that in. Positive, nope, I'm not interested in that one. And then negative, so I'm interested in this region. And now, because we have less than or equal to, we once again have to decide which of these endpoints we're going to include. Now again, remember from the previous example, that doesn't mean that we're going to include every single endpoint. We're going to include the x values that make the numerator 0, but not the denominator 0, which would make the rational expression undefined. So let's see what happens at each one of these endpoints. So negative 5 halves, if I plug that in, that came from this factor in the numerator, so that means I'm going to have a 0 in the numerator. 0 in the numerator is perfectly acceptable. So we have 0 equaling 0, that's acceptable. So I'm going to put a square bracket on that negative 5 halves. Well, how about the negative 2? Negative 2 came from a factor in the denominator. That means we're going to have a 0 in the denominator. That makes my expression undefined. I don't want to include that then. How about negative 1? Well, negative 1 once again came from the denominator, so I don't want to include that either. So now, as we look at what is colored in here, we can write down our answer in interval notation. So we have a square bracket, and we started at negative 5 halves, and then we keep on going until we hit negative 2, but we're not including that negative 2 because once again it makes the denominator 0. So we'll put a parenthesis to demonstrate that. We have a separate chunk, so we need to have a union symbol. And we're going to start up again at -1, again using that parenthesis because we're not including that -1. And then we go forever to the right. And there's our answer. So square bracket, -5/2, comma -2, union, and then parenthesis -1, comma infinity.